Hello everyone. In this video we're going to be proving an inequality which is known as the AMGM inequality for three numbers. So x, y, z are all greater than or equal to 0, and we're going to prove that the arithmetic mean or the average of x, y, z is greater than or equal to their geometric mean, which is the cube root of their product. Okay, so let's go ahead and get started. Now, if you are trying to prove an inequality, there's a couple different ways to go about it. You can start with a well-known inequality, use it to prove the given inequality, or you can use different approaches. And that's what I'm going to do here today. I'm going to subtract these two expressions and write this as x plus y plus z over 3 minus the cube root of x, y, z. And I'm going to call that d for difference. Now, I'm going to make a common denominator, and the reason why I do this is if I can prove that the difference of these two quantities is greater than or equal to 0, that implies the given inequality. Let's make a common denominator here. That gives us x plus y plus z minus 3 times the cube root of x, y, z all over 3 is equal to d. Now, to get rid of the fraction, we can go ahead and multiply both sides by 3. X plus y plus z minus 3 times the cube root of x, y, z equals 3d. Okay, so now we got rid of the fraction. We have a nicer expression, but we still need to simplify this or prove that this is greater than or equal to 0. How do you prove that? I'm going to use one of my favorite methods, which you well know, I think by this time, is substitution. So I'm going to replace x with a cubed, y with b cubed, and z with c cubed. Of course, this implies that the cube root of x is a, and so on and so forth. So we're going to make the replacements. Replace x with a cubed. We get a cubed plus b cubed plus c cubed. And then the cube root of x, y, z, they're all equal to abc. Their product is going to be abc, because when you cube root it. So it's just going to be minus 3abc. I don't know why it's making that. Okay, minus 3abc is equal to 3d. Okay. Now, this expression on the left-hand side, you may have seen this before, and I believe in another video or a couple of videos, maybe I don't remember, we used this expression, we factored it, I think. We can double check on that one. But this should be familiar to you somewhat if you are dealing with factoring polynomials. But anyways, we're going to start from scratch, and we're going to be simplifying this expression. In order to simplify this or factor this expression, I'm going to start with something like this. I'm going to replace a cubed plus b cubed with something else, and that is a plus b cubed minus 3ab times, I don't know why Notability is acting like this, 3ab times a plus, okay, great, times a plus b. That is equivalent to a cubed plus b cubed. As you know, if you expand from binomial theorem and do a little bit of factoring, you're going to get that. So I'm going to be using that expression. And then this is, again, 3d. Now, this makes our expression factorable by grouping, sort of. So I'm going to take these, put these two together. So write it like this, a plus b quantity cubed plus c cubed. And then the other two terms, here and here, I can take out a negative 3ab. And then inside the parentheses, I should be getting a plus b plus c. So this is equal to 3d. I don't really have to write 3d every time, because we know that this is equal to 3d. Okay. Now, what can I do with the a plus b quantity cubed plus c cubed? Well, notice that it is sum of two cubes. So I can actually factor it, and remember that x cubed plus y cubed can be factored as x plus y times x squared minus xy plus y squared. That's what I'm going to use. So I can write, and in this case, x becomes a plus b and c becomes y. So I can write it as a plus b plus c as my first factor, and the second factor is going to be a squared, which is a plus b squared minus AB, which is C times A plus B, plus C squared. So that is the first part. Minus 3AB, A plus B plus C is just going to stay the same. Now notice that A plus B plus C is a common factor, so we can take that out. Now when we do, we're getting A plus B squared. Let's go ahead and expand it. A squared plus B squared plus 2AB from here. And then minus AC minus BC plus C squared. And then from that, I just need to subtract 3AB. And that's going to be the whole thing, basically, right? Okay. So this is what it is. And C squared is here, and so on and so forth. We already pulled out A plus B plus C. We don't have to worry about it. Now, A plus B plus C is, pretty simple. Let's go ahead and simplify the second one. How can I do it? Well, I have 2AB minus 3AB, so I can go ahead and subtract those, and that should be minus AB. But first of all, let's write A squared plus B squared plus C squared minus AB minus AC minus BC. Now, if the expression in the second set of parentheses were A plus B plus C or A minus B minus C quantity squared, that would be nice because that would always be greater than or equal to 0. But that's not the case, but don't worry about it. We're still going to manipulate this expression for our needs. So now I'm going to work with this expression. Let me go ahead and isolate it because A plus B plus C is good. Let it be there for a while. Now I'm going to take this expression and I'm going to call that expression, I don't know, maybe E, something like that. Or let me do the following. Let's go ahead and double this expression. Let's multiply everything by 2. I can also do the following. Like I can take out a 1/2 and then double everything inside the parentheses. How about that? That's probably better. 2A squared plus 2B squared plus 2C squared minus 2AB minus 2AC minus 2BC. So this is equivalent to our expression. Now 1/2 is needed because I needed the 2's inside. Now I can separate these into pieces now. I can write A squared minus 2AB plus B squared, and then I can write B squared minus 2BC plus C squared, and then I can write A squared, because I do have an extra A squared, minus 2AC plus C squared. Now notice that I have A squared plus B squared plus C squared twice, and then I have the AB, BC, and AC twice being subtracted from the whole thing. So they're equivalent. Now this gives us an opportunity to write this as a sum of squares. This is A minus B squared, this is B minus C squared, and this is A minus C squared. And as you know, sum of squares cannot be negative. Therefore, our expression, the second factor in our expression, is always greater than or equal to 0, which is this one. So this expression is always greater than or equal to 0. A plus B plus C is always greater than or equal to 0 because A, B, C are all greater than or equal to 0. That means our expression here is always greater than or equal to 0 as a result of this. Great. Now where does this come from? Well, it comes from this expression being greater than or equal to 0. So this basically proves that A cubed plus B cubed plus C cubed minus 3ABC is always greater than or equal to 0 if A, B, C are all greater than or equal to 0. Great. Now we can go ahead and back substitute, replacing A cubed with X and B cubed with Y, C cubed with Z, and then you know the rest, the cube root of X, Y, Z. And this implies that this quantity is greater than or equal to 0, which was 3D, remember? And this also implies that X plus Y plus Z is greater than or equal to 3 times the quantity or the cube root of X, Y, Z. And then from here we can divide both sides by 3, and X plus Y plus Z divided by 3 is greater than or equal to the cube root of X, Y, Z. And this is actually what we were trying to prove, which is the AM-GM inequality. And this brings us to the end of this video. Well, I hope you enjoyed it. Please let me know. Thank you for watching. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.